Okay, well, I accidentally hit stop on the video, so it looks like this one will just be a two-parter, but we're continuing on writing exponential functions. And so we've got a graph now that shows a stock since it was purchased, and we want to write the function that best models what the value of it is. So again, we have our b value, where our y-intercept is, or our a value, sorry. And then we're jumping up one each time, but the number that we are going up by or getting multiplied by, we're not really sure of. So what we've got to do here, since we don't know it, is use our one of our fact families. So I would say 24 times something equals 19.2. And so if I just divide both sides by 24, then I will get what that number is. And so doing 19.2 divided by 24, we could work that out or put it in a calculator, but you're going to get 0.8. And so checking to make sure it's correct, this is a downward slope. So we're saying, yeah, that seems like it should be right because it's going downwards there. So my b value is going to be that 0.8. And now we've got y equals 24, 0.8 to the x power. Looking at a couple more here. We've got a table that shows the number of teams remaining after each round of a softball tournament. And so we have, just like most tournaments, it gets cut in half each time. So half of 32 is 16. There's a half there. So looking at that, we know our b value this time is 1/2. But when it's 0, we don't know what that is yet. And so working backwards from that, going forwards, I was multiplying by 1/2. So backwards, I'd be dividing by 1/2, or you could think of it as multiplying by 2 to get where they started out. And that would be 64. So a little bit of extra work there to get our a value, but just working backwards one or two, typically not a problem for us. So started out with 64, and then it's 1/2 to the x power. Okay, and then we've got a couple more we'll look at here. So we'll use the information we have and try to do these last couple. So looks like on this one, I've already got my a value, which is 2. And it's great because I know I've only got two numbers that I've got to figure out here that are right next to each other. But keep in mind that we're also going to be, because obviously when you're doing star tests, you're not going to have just tables that represent exponential functions. You could also have a quadratic function. You could have just a regular linear function. The thing that's going to differentiate it here is that when I'm going from one to the other, what's happening to it. So as I add 1 each time, what's happening here? So when I go from 32 to 8, it's like I'm taking 32 divided by 4, which is the same as multiplying by 1/4. 8 times a fourth, we're just checking to make sure it's the same thing each time. There on that. And that it keeps going downward. If they don't show you a change here, then it's not going to be a quadratic function either. So now I've got my a value. My b value would be 1/4. So we just write it as y equals 2 times 1 over 4 to the x power. Same thing here. Again, I have my a value. And as I go up 1, from 1 to 3, it's times 3. So it looks like I'm multiplying by 3 each time. So y equals a value, which is 9, times 3 to the x power. Okay, and on these, remember as we're looking at them, so just remember we're also going to be thinking about some of those attributes. Mainly we've got our y-intercept there. Looking at it, this b value, and it's less than 1, that we know it's decay. Just like this one down here, that would be growth. We don't really have necessarily a sense of, well, we do, since there's nothing being added or subtracted to this. My asymptote still is going to be y equals 0, because no matter what I make that x value, I can make it negative 100, so it's going to give me a really, really tiny fraction, but we'll never go into a negative number. Only way it could do that if there was like a -1 behind this, so asymptote would still be the same. We could find domain and range from this. Only time your domain and range is going to be different is if you have something like the stock value one, where number of months, we don't go into a negative number of months. So my range, instead of being all real numbers, would just be x is greater than or equal to 0, because it starts at 0 there and just moves on forward with that arrow. And we could say y is, like for your range, y is greater than 0, less than or equal to 24. So these, it'll kind of change your domain and range a little bit, but almost makes it easier when you've got a definite starting and ending point. So looking at the last one, we're going to go with what we know here to figure out which function matches up with this. The first thing I notice is that this a value is 3. So since that is not a 3 there for my a value, I know I'm out from that. And then I just need another definite point on here. So it's like I have 0, 3, and 1, 2. So multiplying, what would I multiply this by to get to that? And so if I multiply it by 2 and divide it by 3, that would work to get me what I need. You could also just say, well, 3 over 2 is bigger than 1. If that was the case, it would be growth. So 2 over 3 is what's going to make it decay, because it's a fraction that's less than 1. So that gets us our answer here. H of x is equal to that. You've also got the option of, if you type it into Desmos, each of these, you'd see pretty quickly which one looks the most similar to that.